Good afternoon, everybody. Good morning still. My name is George Kazangi. I'm a solutions architect at Triforce Australia. As Chris mentioned, Triforce is a HP Premier partner. We work with HP on delivering new technologies and as well as from a services point of view, implementing technologies such as the HP Pod, which we'll see here today. I'll just touch quickly on the, as we see the data center landscape. Most data centers in Australia quite simply are full, whether it be real estate or lack of power. Most of the need in Australia is around a Tier 3 data center. When I say Tier 3, I'm referring to the Upcoming Institute, which a lot of data centers in Australia don't closely follow. Apart from space and the actual real estate, especially some of the customers we've been working with quite recently, some heritage listed buildings, for example, a lot of construction can't happen inside, or not easily inside some of those buildings. Power and cooling, the common, I guess, common thing we're talking about here is the PUE rating. As Steve and Chris mentioned, we've actually also seen between 2 and 2.5 PUE rating on most of the data centers that we work within. Some of the issues we have around that are not just the cooling, but in power, especially around CBD areas. Very public that Sydney lost power, I think, 3 times last year, the CBD itself. So perfect opportunity to run something in Wyong. It didn't actually quite affect Wyong. And the escalation in power costs. One of the things we work through with some of our customers is not just the initial capex of building something, building a data center now to a certain rating, but also in expanding into the future. Most data centers aren't easily expandable, whether it be via cooling or power or even supply from the utilities companies. But also things like weight ratings on the floor and the ever-increasing density of server and storage from HP and other vendors. Our experience in design. I'll touch quickly just on this example being Verve Data Center. One of the things you really need to consider with containerized data center is the sheer weight. So we talked about density and how modular the data center is, and especially the pod itself. But with that comes other challenges such as weight. So I'll give you a rough figure. A lot of the data centers in Australia, the Tier 3 data centers, don't allow you generally to put more than 1 HP blade chassis per rack. And that's for 2 reasons, or 3 reasons, power, cooling, and weight. Some of the HP blade chassis, you could fit 32 servers in a space about this size, and 10 RU, and they can weigh up to 200 kilos. So you start to run into some of the things you need to consider when putting in an HP pod. You get a lot of advantages with an HP pod. When we go through the walkthrough a little bit later, you'll see that it supports 1,300 kilos per rack and 27 kilowatts, as Chris mentioned. But you'll also see the sturdiness and pure weight of the pod, as well as all the infrastructure inside, really needs to be considered when choosing a location or designing data center around HP pod. From an internal computing infrastructure, we'll touch again on this when we walk through the pod, but there is only little consideration apart from it fitting into a 19-inch rack, and that is the way the PU rating on this pod is achieved is by isolating the cold aisle and the hot aisle. So making sure that really you're being as efficient as possible, always serving cold air into something that actually needs it, not to the general area as most data centers in Australia. The other, I guess, key message around the containerized data center is how easy it is to manage the data center. So once the pod is deployed, apart from its own built-in building management systems, it comes with its own fire suppression, fire detection systems, as well as its own control over every element that's inside that pod. And again, when we do the tour, we'll point out all the features of the pod. Applying the pod to current business needs. we mentioned before that high-performance computing and data center expansion. From our point of view, they're the two key drivers that we see that particularly fit the HP pod today. Data center expansion is an easy one. Heritage listed buildings, running out of capacity, whether real estate or power. The HP pod and some of the designs we've done quite recently are putting into 2 or 3 car spaces. So in Australia, you can quite easily measure what the cost of a car space is because they charge you by the hour. But also in things like basements, under trees, we've had a couple of inquiries there, as well as living in the back of a truck or the back of a semi-trailer and powering it on that way. So you can get quite creative into all the opportunities of actually deploying this pod. The other one is high-performance computing. One of our customers has come to us and said, look, we're a render farm, for example. We do some of the world-recognised movies, and we have a lot of blades, and seasonally we need to turn them on and off and move into certain areas. One of the issues that they have is they're in probably one of the top 5 data centre in Australia, and it itself has issues with power and cooling. So the data centre itself has been modified to a point to be able to accept this customer seasonally. The issue now is this customer now has a new movie, they want to deploy it in time, and there isn't space or cooling capacity to add extra computing power into this data centre. Funnily enough, this data centre is a worldwide based organisation that has multiple data centres around the world, and is generally, the data centre was not designed for this type of computing load. With the HP pod, we're able to design a solution for them where we could move all that computing infrastructure straight to the car park of their own premises. So that saves them on a lot of networking costs, for example. And one thing that Chris didn't mention in Australia, it's quite a large landscape, and one of the biggest challenges around data centres in Australia and the shift to go into a managed data centre is latency on networking. Because of the sheer distance, moving this IT load to the customer's premises saves them on some of those challenges, but also allows them to put 3 times more computing power right at their premises. In talking about Verb Data Center, one of the challenges was how can we reduce the capital expenditure and get all the facilities that we need day one, but also have a very easy and efficient upgrade path to increase the amount of computing power we can support over the period of time. And when we walk through the tour a bit later, you'll see that in some way the room has already been separated for the addition of extra pods. And when Chris shows you through the utilities, you'll see that it's done in such a way that for expansion we can add extra utilities to that live without any interruption to service. So these are some of the considerations we look at when actually deploying the pod. Something else looks like that here, but let's go to the next slide. There you go. Okay, provisioning time. Chris mentioned 14 weeks to provision a service. So from the time that Triforce got involved in designing this data center, we did some site assessments, things like ensuring that the ground could actually support the weight, not of just the pod, but all the possible combinations of putting computing infrastructure inside that pod. From the time we first got involved, we then had the order placed, thank you Chris, and then 14 weeks later we have a fully functional data center. It's not in operation as yet, but as you'll see today, 14 weeks is a pretty good achievement. From the time we ordered the container, which generally takes in Australia 12 weeks from the time you place the order with HP to physically hitting the ground. Although that took 12 weeks to do, what they gave us the opportunity to do is actually build the facilities and have them well and truly prepared and tested prior to the pod actually arriving. So it gave us a period of about 12 weeks to have things like chilled water and chillers installed, power substations increased, power being run from the actual utilities company themselves, even though they're just around the corner here. as well as putting things in like BMS, fire suppressants, and actual building works, which is a large piece of this data center. So 14 weeks is a pretty good achievement. I agree with Chris, it's very difficult to get a bricks and mortar-based company up and running in that period, especially with the density that this pod actually provides. I'm just going to go quickly through some photos of this site actually being developed. So this is actually an HP pod arriving about a month and a half ago. This is actually the 20-foot container, and it arrives exactly as it is, straight from a ship that hits Port Kembla in Sydney's case, and it gets trucked up here and ready to put into a warehouse. You'll see on the right and left-hand side, we actually have 2 cranes. The warehouse that it went in is actually the same height as this warehouse here. It's pretty much exactly the same, but maybe a lot wider. And we had a very narrow space to get this pod in. And I guess this really highlights how flexible and how, let's say, how modular this pod is. So in a traditional data center, to get all the facilities in one, you couldn't fit them through that door. Here we're moving, if you like, the container itself, which inside includes the 10 50 RU racks, which you'll see, as well as the smarts, switchboarding, fire suppression, things like that. So this actual pod right there weighs just under 9 tonnes. I'm not sure what it is in the other measurement, 9 tonnes. We're actually getting into the data center here, so because we couldn't use conventional methods and we couldn't simply just reverse a truck in here, which is the ideal method, the first crane goes in and lowers its straps, and the second crane follows it straight behind. So, though it looks like it's sitting on the ground, I don't think it is. It's about 4 inches away from the ground here. And it's sitting in this final destination, and you'll see that the concrete plinth that was actually built as part of the design, just to support the sheer weight of computing power that we're able to put into the pod.